Hello, I hope that you enjoyed the first lesson, getting us ready for trigonometry. Today we're going to learn 3 of the 6 trig functions. We're going to define what trig is, and then we're going to learn the ratios of sine, cosine, and tangent. Those are the 3 that we're going to learn today. The other 3 we're going to learn tomorrow. So let's get going. Trigonometry. It's the study about relationships. This trig reflects so many characteristics of God. It's crazy. I mean, God is all about relationships. He's all about redeeming relationships. He's all about having relationships be consistent. And these ratios are incredibly consistent from triangle to triangle to triangle. So it's really a wonderful reflection of God's character, how he created these trig ratios. A trig ratio, it's a fraction, nothing more than a fraction. Okay? Fraction that compares, so that means one's going to be in the numerator, one's going to be in the denominator, the lengths of sides of a right triangle. Other triangles too, but we're focusing on right triangles. Alright, so a trig ratio is just a fraction of side lengths. Okay, particular side lengths, when you compare particular side lengths, then you are working within a trig function. So a trig function is a specific rule given by a ratio. There's a total of 6 of them: sine, cosine, tangent, cosecant, secant, and cotangent. Okay, today, boom, first 3. All right, first 3 today. Okay. All right. Okay, so the functions are these things on the left: sine, cosine, and tangent. Each function has a unique ratio. Now don't be alarmed by this theta here, okay? Because remember how we had 2 acute angles for every right triangle? Well, this theta says it's the same thing for either one. You just have to pick up the correct sides. So for any theta, acute angle theta in a right triangle, the sine of that is opposite, the side opposite to that angle, over the hypotenuse. Remember, the hypotenuse is the same regardless of which angle you're looking at. Okay. The cosine of that same angle is the side that's adjacent to it divided by the hypotenuse. And the tangent is the side opposite over the side adjacent. Now, the one thing you're going to have to push against is you're going to have to push against writing these in decimal form. Don't do that. Just simplify your fractions, all right? There's a very easy acronym for many years. Okay, I'm not even going to say. All right, but it's called Sokkatoa. Sokkatoa. It kind of just runs right off your tongue. Sokkatoa. And sine is the opposite. Sine is the opposite over the hypotenuse. Cosine, whoops, why do I not have my laser pointer now? Cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Those are all sides. The S, the C, and the T are the functions, and the other letters, the littler letters, are the sides. Sometimes, when I was younger, learning to do this, I would write it a little bit differently. I would write it like this. So, that's an H. Whoops, my bad. Toa. Sokkatoa. Okay? The other 6 functions, we're going to talk about these tomorrow, so I'm just going to hang on. They're the reciprocals, but I'm going to hang on and talk about those a different day. So let's start working with Sokkatoa. All right? Write the trig ratios of sine, cosine, and tangent for each of the acute angles of the right triangle. Include the formula and simplify all radicals. No decimals. No decimals. Okay? All right. So you have to look at each angle separately. So here's angle A right here. Now where is the side opposite? Well, this is opposite. The hypotenuse is always across from the 90-degree angle, so there's H, and then that leaves this one to be A. All right? So the sine of angle A is the opposite over the hypotenuse, Sokkatoa. All right? Sokkatoa. So the value of my side opposite angle A is equal to 8. My hypotenuse is 10. All I have to do is simplify that by dividing top and bottom by 2, and I get 4/5. The cosine of the angle is adjacent over hypotenuse. My adjacent side has a measure of 6. My hypotenuse, is 10. Not H, it's 10. And that equals 3/5. And then the tangent is the side opposite over the adjacent. The side opposite is 8. The side adjacent is 6. And I get 4/3. Right? Works the same way for B. Okay? I'm going to erase these. Okay? And I'm going to focus. So when you do these, you're going to want to use pencil. And you're going to want to give yourself some little notes. So this is my opposite, this is my adjacent, this is my hypotenuse. All right, so here we go. Sine of B is opposite over hypotenuse, which is 6 over 10, which when I reduce it is 3/5. The cosine of B is the side adjacent over the hypotenuse, adjacent over hypotenuse. That's 8 over 10, or 4/5. And the tangent is the side opposite over the adjacent. And so we're going to get 6 over 8, which is equal to 3/4. Okay? All right, here we go. Easy peasy lemon squeezy. Let's try another one. This one's going to be a little bit more difficult because we're going to have to rationalize this radical right here. We have a radical in a side length, so we're going to have to practice rationalizing. All right, so let's focus on side A, and then this is my opposite, this is my adjacent, this is my hypotenuse. Remember, the hypotenuse is always across from the right angle. The sine of A is opposite over hypotenuse, which equals 3 over 6, which equals 1/2, 1 reduced. The cosine of A is the side, remember Sokkatoa, Toa. Okay. The cosine of A is the side adjacent over the hypotenuse, which is 3 square roots of 3 over 6. Right? Now notice that I can't do anything with the square root of 3, nor do I need to, the square root of 3, because it's in the numerator and it's prime. So I can't do anything with that. But I can reduce this 3 on the outside with the 6 in the denominator, and that gives me the square root of 3 over 2. Now the tangent of A is going to be the side opposite over the adjacent, and that is going to be 3 over 3 square roots of 3. Now here I'm going to have to do something. These cancel, and I end up with 1 over the square root of 3, and all I have to do is multiply top and bottom by the square root of 3. That's it. This goes to 3, so I end up with square root of 3 over 3. The sign of B, now I'm going to erase. Okay, and relabel. The sign of B will be, this is the hypotenuse, this is the side opposite, and this is the side adjacent. So the sign of B is opposite over hypotenuse. Sometimes my H's look like N's, my bad. And I get the square root of 3, or 3 times the square root of 3 over 6. Whoops. I just want it to go away. There we go. All right. And when I cancel that, oops, there's a 6. I get the square root of 3 over 2. The cosine of B is the adjacent side over the hypotenuse, which is 3 over 6, which simplifies to 1/2. And the tangent of B is the opposite over the adjacent, which equals the 3 square roots of 3 over 3. These cancel, and you're just left with the square root of 3. Okay. Let's try another one with a square root. All right. Here is angle A. Oh, I didn't leave myself much room over here, did I? That was silly of me to place it like that. Okay, here we go. So this is my adjacent side. This is my hypotenuse because it's across from the right angle. And this is my side opposite. All right. Sine of A is opposite over hypotenuse, which is equal to 4 over 4 square roots of 2, which is 1 over the square root of 2, which is 2 square roots, which is the square root of 2 over 2. That's an equal sign in there. Okay. The cosine of A is opposite over hypotenuse, adjacent over hypotenuse. Caught that one. And it is going to be the same thing. If you look at it, you get 4 over 4 square roots of 2. Those cancel. 1 over the square root of 2, which simplifies to the square root of 2 over 2. Anytime you have 1 over a square root, it ends up with the square root of that number divided by whatever's underneath that radical. Always happens. And then the tangent of A is opposite over adjacent, which is 4 over 4, which is equal to 1. We're going to see in a couple of days that this is a 45, 45, 90 triangle. I'm going to skip this because I didn't leave enough space for it. All right. Find the missing side, then write the trig ratios of sine, cosine, and tan for each of the acute angles. Include the formula and simplify all radicals. Okay, so here's where we're going to pull in what we learned about the Pythagorean theorem. I need to find this side right here. Is it a leg or is it the hypotenuse? Well, it can't be the hypotenuse because I have a value. It must be a leg. So let's just call it B. How's that? And I have A squared plus B squared equals C squared. And I'm going to plug in 5 for A, and I get 25 plus B squared is equal to 169. Gosh, that really looks horrific. Oh, I'm so sorry. I'm going to see if I can fix that in a hurry. There we go. And so b squared is going to equal 144, and b is going to equal 12. So this has to be 12. Okay. Now, over here we're looking at sine theta. All right. Okay. So I'm going to erase that little b. Okay, because I used that to get my value, but now I don't really need it. Now I need to think in terms of opposite, adjacent, and hypotenuse. All right? So for sine theta, 5 is my side opposite, and 12 is my side adjacent. So for theta, opposite over hypotenuse is 5 over 13. Cosine is going to be the adjacent over the hypotenuse, so that's going to be 12 over 13. And then my tangent is going to be my opposite over my adjacent. So I'm going to get 5 over 12. Now for beta, I have to change which side is adjacent and which side is opposite. So I'm going to do a little erasing here. Okay. And then I'm going to label, oops, I need to erase this thing here too. I'm looking for beta, so here's my side opposite, here's my side adjacent. All right, so here we go. Opposite over adjacent is going to be 12 over 13. Cosine is going to be adjacent over hypotenuse, 5 over 13. And then the tangent is going to be the opposite, which is 12 over 5. Simplify, but don't write them as decimals. Okay. Let's try one more where we have to find the length of a leg or the hypotenuse. All right. So we're missing a side here. Okay. We need to find this. Let's just call this A for right now. Not A for adjacent, but A for a leg. All right. So we're going to have A squared plus B squared equals C squared. All right. A we don't know, so we have A squared plus B squared is 64 is equal to C squared, this is C, right? 144. Okay. So now I have to solve for A squared, and I'm going to get 80. And now I have to simplify that radical. And I'm going to divide both sides by 5. Oh, come on. I'm going to well, I'm having a little bit of problem here. All right. Oh, yay. Okay. So I'm going to... Well, that is like really weird how this is going on. And quite frustrating, I might add. I'm almost through. I'm sorry about this. I just fear that whenever I go to write on it, something's going to happen. Oh my goodness. I'm going to try and skip that slide altogether. Let's try this one. It'll be a little bit more difficult. Let's see if we can if I still have the same problem here. Again, I'm looking for a leg. Okay, looks like I've got something happening here. All right, that's 5 and 16 is a perfect square, 4 and 4. So this side here is going to be 4 times the square root of 5. All right, sorry for that. Okay, here we go. I'm just going to do one side because the other side is very similar and I've lost a lot of time on that. So I need theta. I need to label the hypotenuse and the opposite and the adjacent. So here's theta, hypotenuse, opposite, adjacent. So let's move on. We have the sine of theta. This angle here is opposite over hypotenuse. So I get 8 over 12, which reduces to 2/3. The cosine of theta is adjacent, 4 square roots of 5 over the hypotenuse. And then I can cancel here and I get the square root of 5 over 3. Notice that since my radical is in the numerator, I don't have to rationalize that. I'm good. And then I get opposite for tangent over 4 square roots of 5. This one I do have to rationalize. I'm going to cancel this first, and I get 2 over the square root of 5, which I'm going to multiply by the square root of 5 over the square root of 5, and I get 2 square roots of 5 over 5. Just like that. All right, let's do this one. I'm going to, seeing as I did theta the last one, I'm going to do beta on this one. So first we have to find this missing side, and we have to use our Pythagorean theorem. So I have a leg and a hypotenuse. So I have a squared plus 15 squared equals 17 squared. All right, so I know 15 squared. A squared plus 225 is equal to, I believe that's 289. 89, sorry you can't read that. Wow, trying to hurry and it's causing me to waste a lot of time. A squared plus 225 is equal to 289. I'm going to subtract 225 from there, and I get a squared is equal to 64. You hear Eli in the background? So a is going to be 8. So that's this side right here. Now I'm going to let go of a, b, and c because I need to think through opposite, adjacent, and hypotenuse. So this is my hypotenuse, doing beta. This is my adjacent, and this funky little thing right here is my side opposite. So I'm going to move over here, and I'm going to go the opposite over the hypotenuse is 8 over 17. The cosine of beta is the adjacent over the hypotenuse, adjacent over hypotenuse, and that's going to give me 15 over 17. And then finally my tangent is opposite, which is 8, and adjacent, which is 15. Okay. Now finally, one of the things that we like to do is we'll be given a trig function and its value, and then we have to find all the other ones. And you're like, huh? But think about it. All right, so the directions you're going to read, you have a right triangle, and you have two angles that are acute. Here they're theta and beta. Theta and beta. Okay. and these are your acute angles, and they want you to find the sine, the tangent, and the cosine, the sine, cosine, and tangent of both of them, if you know what the cosine of theta is. Now watch how this works. If we know what the cosine of an angle is, then we know two sides, don't we? We know the side that is adjacent over the hypotenuse to theta, So here's the side adjacent to theta, so that must be 3, right? The hypotenuse must be 7. So now we're going to use the Pythagorean theorem to find this other side right here. And we're going to get 3 squared plus b squared equals c squared. So I didn't make enough room. B squared is going to be 49 minus 9. So that's the square root, that's 40. So I have the square root of 40, which is equal to 2 square roots of 10. All right? Okay, so this thing must be 2 square roots of 10. I don't get all good coverage when I don't get close to the edge there. 2 square roots of 10. All right? So again, in hopes of saving a little time, I'm going to do theta, and then you can do beta on your own, and I can give you those tomorrow in class. All right? Theta, we're going to label the side opposite, the side adjacent, and of course the hypotenuse. All right? The trick to these problems is recognizing what they give you. It's kind of incognito, but they give you 2 of the sides, okay? All right, so now opposite is 2 square roots of 10 over 7. The adjacent, well, we were given this. That's 3 over 7, so you just kind of rewrite that. And then the tangent of theta is going to be the side opposite, which is 2 square roots of 10 over 3. Just like that. Let's try another one. All right. You're going to find the trig functions requested, given that the tangent of theta is 7 over 12. Remember what that ratio is. Tangent. TOA. This is the side opposite over the side adjacent. All right? So here's theta. The side opposite is 7, and the side adjacent is 12. Okay? Don't look at the actual. I know it looks like this side could be longer. Don't worry about that. All right? Just label it as it is. Okay? And then we have to figure out what h is. So that's like c using the Pythagorean theorem. So I have 12 squared plus 7 squared equals c squared. So that's 144 plus 49, which is 193. So c is going to be the square root of 193. Okay? It's not divisible by 3 because that doesn't add up to a number divisible by 3. So I'm just going to leave it there, just like that. So we have the square root of 193. If it's divisible by 7. Nope. Okay. All right, here we go. We have the side opposite, the side adjacent, and the hypotenuse, right? I'm going with theta again. You'll do beta on your own, and we can check it in the morning when you come to class, right? The opposite is going to be 7 over the square root of 193. So that's going to give me, I have to multiply top and bottom by square root of 193, which just gives me 7 square roots of 193 over 193. There's your answer. Okay. Adjacent is going to be 12 over 193 square root. Multiply top and bottom by 193 square root.
and you get 12 square roots of 193 over 193. And then OA, our tangent, is going to be what they gave us, 7 over 12.
Okay.
Now for these over here that you do, you're going to label your sides a little bit differently because you're going to be focused on this angle. Okay? The numbers stay the same, but your opposite and your adjacent changes. Okay?
This will be your homework. I'll have a worksheet for you. Go ahead if you can and just kind of start writing these key things that you need to know. All right? It's going to help you. If you can commit them to memory, then it's going to help you. All right? Thanks for listening, and I will see you tomorrow in class. Good night.